All right, so this time we have a point and we're given a line, and what we want is the equation of another line L2, in the plane R2 through this point P -1, 2, and perpendicular, it's telling us, apparently, hopefully that says perpendicular, to the line L1. This is math, not English. There will be spelling errors. We have a line in general form. So classically what we're going to use is all three avatars of the point in the plane. They've given us one in the general form, or the general avatar. Then I'm going to turn that and solve for y to put it into y equals mx plus b form, or the slope intercept avatar. And then once I have the slope, I can use this condition perpendicular to find the slope of the line I need, and then I have a point, and I can use the point slope form of the line to create the equation of the line. Step 1. Basically, they've given me L1 in general form. I want the slope of this so that I can compare in my conditions what the slope of my new line is. So I have 3x plus 5y minus 1 equals 0. I'm solving for y, so this is if and only if 5y equals negative 3x plus 1. I bring the 1 over, I bring the negative 3x over. Now I can divide by the 5. So this is if and only if y is equal to negative 3 over 5x plus 1 over 5. The point of that is, now that's what I was just saying. This is the general form. This is now the slope intercept form of this line. We transformed it. So why did I do that? Because the slope, the number standing in front of x now, is the slope. So m1 from my first line is negative 3 over 5. And that's what we need in step 1. Now that we've done that, we have slope m1. I'm going to use the perpendicular or the parallel condition to see whether or not I have to calculate, just use the same slope, or calculate some other slope for the perpendicular condition. In this case, we do have perpendicular condition. So the next step we're going to do is, what I have is almost everything I need. I need my slope m2. This is the point that's going to be on my line L2. And I need my slope m2. And we don't know what that is. Once I have the slope and the point, I can use the point slope form of a line to generate this line. After you drink coffee. Always after coffee. They said L1 was perpendicular to L2, which says there's a condition or a theorem which tells us this is if and only if M2 is the negative reciprocal of M1. So negative and then reciprocal. So I have M1, and that's what, now the last calculation we have a theorem, and coincidentally I might as well give the other condition. L1 is parallel to L2 if and only if M2 equals M1. You get a mulligan, you get to a freebie. So that's not what we have in this case, but if that's what they ask you, you get the condition for free. Expect the perpendicular condition at least once on an assignment or on an exam, because it's the calculation. Either way, I now know that because these lines are perpendicular and I have my point. The last calculation I need before I build this avatar of L2 is M2 is negative 1 over M1. Every time, even though I just did it here, I still write it down again for myself, and now I put in the parts. This is now negative 1 over negative 3 over 5. Immediately the negatives cancel, and I get division of fractions, which gives me 5 over 3. So what was that? M2, the slope I needed. Now I have a point and a slope I need. That's all I need, and now we're going to build the point slope form of that line, which is always y minus y naught equals mx minus x naught. If this is your point p naught, x naught, y naught in general. And then now my mind puts the example pieces in there. I have a point p naught, which is x naught, y naught, and a slope m2, which is 5 over 3. So this becomes y minus 2 equals 5 over 3 times x plus 1. You can simplify if you want to put it in point slope form, but this is the, or slope intercept form, but this is the equation of that line, L2. So coincidentally, I like these problems, and so do most of the books and the instructors, because it uses all three avatars of the equations of lines. The original problem gave me the general equation. That's supposed to say general somewhere in there. That's an E. then I used in the first step I needed the slope, so I transformed it to the slope-intercept form. Of L1. And then once I had that, I used a parallel or perpendicular condition to find the slope I wanted. And then once I had a slope and a point, I used the point slope form of L2. This was L1. So these problems use all three avatars, which I like a lot. I know that is the cats running around again upstairs. Every time I try to get them better things, they just destroy everything.